all of these questions, do yourself a favor and start with direct substitution. Cosine of 0 is 1. 1 minus 1 is 0. The sine of 0 is 0. Square 0 times 2 also is 0. Unfortunately, this one's indeterminate form. So, your list of things to consider. In calculus, pretty much any algebra thing you've ever done is fair game as far as rewriting it. But for us, we have the luxury of a little bit more time. So you should only worry about factoring. Doesn't look like anything factors yet. Conjugates, probably no need for conjugates unless you've got a square root, or now trig identities. So I've got a cosine here and I've got a sine squared here. So I probably need to replace one of these with something. So what do you think we should try?
Make it 2 minus 2 cosine squared.
Okay, make what?
The sine squared.
Okay, make sine squared be, oops, one more time.
2 minus 2 cosine squared.
Okay, just leave the 2 out front. What is sine squared equal to?
1 minus cosine squared.
1 minus cosine squared. So that first Pythagorean identity from last semester tells us that, hey, sine squared is always equal to 1 minus cosine squared. Now, is that going to be helpful? The first time you work this question, you don't know. But if you don't know what else to try, you've got to do something. So, you should start there. And now you should know that you're trying to look for something to cancel out. So did anybody think of a way to rewrite this? The highlighted part? Very good. It's the difference of 2 squares. I know you guys can factor the difference of 2 squares when I say, hey, this is a difference of 2 squares problem, but sometimes you need to recognize, hey, 1 is a perfect square, cosine's a perfect square. To factor the difference of 2 squares, you need a plus and a minus. Okay, and then, so you kind of had a hint if you're looking at the numerator, because you should know you want something to cancel. If everything in the numerator goes away, that leaves behind a 1. And now as soon as something is canceled, we try to do direct substitution again. Cosine of 0 is 1. So it looks like 1/4 would be the answer.
What are we looking at 2 times 2 on the bottom?
I've got this 2. This 2 is this 2. When you plug in 0 over here, the cosine of 0 is 1 from the unit circle. 1 plus 1 is 2. Again, I'm not going to graph this one, but we could graph this function in the calculator. Look at the x values around 0, and you will see that the y values are approaching 1/4. That's the only way for you to really be 100% sure right now. Okay, so any questions about that one? You guys understand the process to it at least? Okay, now, again, I said I was going to be saying this a lot the next couple weeks, but I'm going to try to emphasize it every day because this was one of the first hard lessons that's really hard for students to accept in calculus. Like, the calculus steps here, just like yesterday, knowing like what you're trying to find with the limit, the y value that it's approaching, isn't a concept that takes a lot of time to understand. Understanding that 0 over 0 means you have to rewrite this and get something to cancel out doesn't take a lot of time to understand. But sometimes you got to multiply by a conjugate. You should know what a conjugate is for years now. You may not have used it much in Algebra 2, but you should have talked about conjugates. Multiplying fractions isn't new. Combining like terms isn't new. Factoring out a GCF is not new. Reducing your fractions not new. But can you do all of those steps without needing someone to tell you what to do halfway through the question is what happens all the time in calculus. And you know, if you can only get halfway through every question, then it gets very frustrating. So calculus really pulls it all together, and that's why the questions end up being quite a bit longer. Not that it's really that much new trig, or algebra. In fact, I'd say there's none. But putting that many algebra steps or that many trig steps in a single question is just more demanding than you guys are used to.